Example of reducing the length of a guitar string. The demonstration deals with an example showing how to change the length of a guitar string playing E1 in order to let play a higher note, G1. We know that the frequency of the vibration of a string is inversely proportional to its length. The string is represented in Cabri expressed by a segment. Select the segment tool. Click at a first place in the window, then at a second place. The segment is created. To call A and B its endpoints, click twice on the button text as it will be used several times. Its icon becomes yellow. Click on the left endpoint of the segment. Type A. Click on the other endpoint. Type B. Letters A and B are movable. The string is the thickest of the guitar. It plays E1. The frequency of G1 is 6/5 of the one of E1. We want to make the length of the string 5/6 of initial length. How to construct geometrically 5/6 of a given segment length. Construct array with origin A. The aim is to construct 6 points on this array that will be endpoints of congruent segments. Hide the point of the array with the Hide Show tool. Select the tool in the top pile and click on the point. Create first a point on the array with the Point tool. Call it C. In order to create the second point at distance AC from C, create a circle with center C and passing through A. Select the Circle tool and click on C, then on A. Create the intersecting point of the circle and of the ray. The same method could be used for creating the third point on the ray. Let's use another method by using the Measurement Transfer tool. First, display distance AC by selecting the Distance tool and clicking on A, then C. Select the Measurement Transfer tool and click on the displayed distance, then on the ray and the second point created on the ray. A new point is created. Here is another method for creating the fourth point. Create the image of the third point in a translation, transforming point A into point C. And again another method for constructing the fifth point as the image of the fourth point in a reflection in a point. Select the pile of the transformations. Click on the newly created point, then on the previous one. Call D the new point. Create the sixth point through a reflection in a point. Create segment EB. Create a parallel line to segment EB passing through D. Create the intersecting point of this parallel line with segment AB after extending it. Call the point F. Line DF is parallel to segment B. According to Thales' theorem, AF on AB equals AD on A. AD on A equals 5/6. Hence AF equals 5/6 of A. If we move point B, the construction of F remains valid. A string with length f will play a note with frequency 6/5 of the note played by a string with length ab for whatever length of ab.